Okay. I'm going to go ahead. This lesson is harder than the one you just did. And clowning around is not going to make it any easier. It's, this is a class that's going to be on the bubble, believe me. All semester, you're going to be on the bubble of passing and not passing. And the whole environment of the class can bring people down. All right? It can. It did last semester. And in the end, I do my best. But in the end, if that's the way you're going to let the classmates be, fine. Okay? I will stop teaching if people are clowning around too much. I just say, watch the video. I'm not standing up here. Okay? So be quiet and listen. And don't ask. Dontavius, you can ask 5 questions, okay? Start counting. Yeah. 5 questions. Look. Yeah, watch out, Dontavius. Your mom might show up again, okay? That happens. Okay? Okay, so this, quiet please. This time we're adding and subtracting. And adding and subtracting is harder because you got to find common denominators, right? You didn't have to worry about that part with multiplying and dividing. Adding and subtracting, that's an added complication, right? So before we talk about adding and subtracting rational expressions, then we just remind ourselves about fractions. First, what if fractions already have the same denominator? How do you add them? And then what? Add the numerators, right? If the denominators are already the same, you don't need to find the common denominator. You just add the numerators, right? That'll be 6 over 7. Right, that's the process for adding fractions that already have the same denominator, which seems kind of simple, all right? But I'm going to tell you that when we get this with the rational expressions, every time, most say, I don't know what to do. But it's the same thing. If we have rational expressions with the same denominator, what are you going to do? Add the numerators, right? I mean, in this problem here, that's the same denominator, which means that when you add them up, right, it'll be 2d plus 1 in the denominator, and now you got to add the numerators, which will be 2d negative 3 plus negative 1 minus 4. What's that? You don't change the denominator. When you add fractions, they have this, okay? So don't turn that kind of problem into a hard problem, which is actually supposed to be the easy problem. There will be some in the homework like that, and that should just be the easiest of them all, right? Don't look at them like, what am I supposed to do there? So with the same denominator, we know how to do that one, right? Mastered. Mastered. We ready there, Dontavius? I'm not, but I want to hook up. Yeah, I don't think you should. Okay, now, what if we're adding fractions that don't have the same denominator? How do you, in this problem here, we would have to find a least common denominator, right? LCD. And you're thinking of, actually, the term that is the least common multiple of 5 and 7. You know, what's the lowest number that both 5 and 7 divide into? And what would you say? Not one is never the answer, okay, ever. What's the lowest? 35, right? 5 goes into 35, 7 goes into 35, which is not surprising because 5 times 7, you're just multiplying the denominators. Right? So if we were going to do that, we would go like this. You'd say, okay, our denominator is going to be 35, because that's the 5 times 7. And then we would have to come back to our fractions and make them have the same denominator of 35. What would I have to multiply the first fraction by so that it has a denominator of 35? Times 7, right? So it's not just 7, it's 7 divided by 7. Right, we're going to multiply. Right, what is the value of 7 over 7? It's 1. So really what we're doing is multiplying times 1, but we're multiplying in the form of 7 over 7. What will we multiply times the second fraction? 5, right? So it'll be 5 divided by 5. Okay, so now this will be 7 times 4 will be 28 over 35 plus 10 over 35, which is, now that they have the same denominator, what's the process? Add the numerators. So that'll be 38 over 35. Right, so first we found the least common denominator. Then we multiplied each fraction to create that LCD in each fraction, and then we added the numerators. Now the last step, sometimes there could be something to simplify at the end. In this case, 38 over 35, are there any common factors? No. So you're done. Most of the time when we're doing with the rational expressions, there's not anything to do at the end to simplify, but every once in a while they throw that in there.
You got to change that.
What's that?
Since the bottom is lower than the top.
No, you can leave it like that. Okay. Now, 7 and 5, that was a particular case that you could just multiply them together, and that is the least common denominator. But is it always the case that when you multiply the two, you get the least common denominator? I mean, in your head, if you multiplied 4 times 6, you would say 24. But is 24 the least common multiple of 4 and 6? Can you think of a lesser number that both divide into? 12, right? So it doesn't always work that you just multiply the two to get that, okay? So first you got to find the least common denominator in a way that we're going to actually be repeating this process with the rational expressions. And this is how you find a least common denominator, even with fractions of numbers, right? First, you factor the denominators. And when it's just numbers, then factoring means 4 is 2 squared, 6 is 2 times 3. Right? That's the factoring part. Now, the LCD will have every factor that you see in either denominator the most times that you see it. So if you see this one's got a 2 in it, so the LCD has got a 2 in it. You go to the next fraction, there's another 2, but we already had a 2. And there's a 3, and so we need to have a 3. And it needs to be the most times that you see it, which means 2 times. In this fraction, it's there twice. In this fraction, it's there once. So the most times it is twice. Right? You don't add them up. You don't say, oh, there's 2 there and 1 there. That means it should be 3. No, then you'd get the 24. Right? Since this is there twice and that's there once, then it's there twice. 2 squared times 3 is 12. Right? So finding the LCD is going to be more complicated than just, well, we're going to multiply this denominator times that denominator. That will be the least common denominator. It will be, that's always a common denominator, but it might not be the least. So let's see. Once we've established that 12 is the least common denominator, what am I going to multiply this first fraction by in order so it has a denominator of 12? 3 over 3. And what am I multiplying the second fraction by? 2 over 2. Right? So this will be 9 over 12 plus 10 over 12. Which is 19 over 12. Can we simplify 19 over 12?
Wait.
No. No, you can't simplify. So that's done.
Before you go on. I'm just catching up. I'm sorry.
Okay, so now we're going to be doing the same thing with rational expressions. And we're going to end up doing like one addition and then 2 u tries and then one subtraction and then 2 u tries. Really the steps are all the same. For whether it's addition or subtraction, it's the same steps, which is we're going to factor the denominators. We're going to determine the LCD. We're going to multiply each term so that we have the same denominator in each fraction. Then we'll add the numerators. All that is pretty standard, right? You state the restrictions at that point. Before you start simplifying and canceling factors, state the restrictions like we did in the last lesson, right? And then if there is something to simplify, which is not common, then you simplify.
Can you just give us one with the common factor already here?
Okay. So we ready? Yeah? Good? Okay. Okay, so first step, what does it say? You just wrote them all down, right?
Factor the denominator.
Okay, well in this case, that will be x over x minus 1. And this one will be plus 2x minus 1 over, and how does x squared minus 3x plus 2 factor?
I would say x squared minus 2x. You would do x.
The factors of 2 that add up to negative 3. Kyron? I didn't hear it. What did you say? Remember, since that's positive and that's negative, they're both negative. So what is it? Yep. X minus 2 times x minus 1. Okay. So now, that's the first step, right? Now we've got to find the least common denominator. The least common denominator has every factor that you see in either denominator the most times you see it. So in this fraction, there's an x minus 1. So the LCD has an x minus 1. This factor has an x minus 2. So the LCT is x minus 2. And it also has an x minus 1, but we already have x minus 1, so we don't have to worry about that. So our least common denominator is going to be x minus 1 times x minus 2. Okay, what do I have to multiply the first fraction by so that it has the same denominator as that? It already has an x minus 1. What is it missing? The x minus 2, right? In fact, I'm going to go like this, right? So this we got to multiply. X minus 2, x minus 2. All right, do we need to multiply the second fraction by anything? No, it already has the common denominator. right? So we're done with that. So it's, then what are the steps next? Well, this was the multiply to get the same denominators. Then what? Add the numerators, right? So this is going to be the denominator of our fraction, and now we've got it simplified. This is going to involve a little bit of distributive property. What is x times x minus 2? X squared minus 2x plus 2x minus 1. All right. Yeah, we need to simplify that. What is that? The negative 2x plus 2x cancels, so we've got x squared minus 1. And in denominator, we still have x minus 1 times x minus 2.
So is it wrong if we did it like that?
Yes. We're not done yet. Okay, now what does this say is the next step? Yeah, what are the restrictions now? Yeah, x does not equal 1, x does not equal 2. I'm going to write that up here. X does not equal 1 or 2. And then the last step is simplify. And this is actually one that we're going to have to simplify. You should look at the numerator and say, oh, that's a difference of squares. How does that factor? X plus 1 times x minus 1. Well, guess what? There's an x minus 1 in the denominator, so it is going to simplify. Right? If I write this like x plus 1 times x minus 1 divided by x minus 1 times x minus 2, then you can cancel the x minus 1s. And what's left? X plus 1 over x minus 2. That's the answer. Right? This is the answer, and with those restrictions, right? It'll ask for both parts of that.
Is that way you can just put this in the calculator?
No. That's done. Okay, so try to do the same thing with that one. Here's the steps are right there. But there's only one little piece of factoring there. How do you factor the x squared minus 4? Difference of squares, remember. X plus 2, x minus 2. I'm just trying to make sure you don't get stuck on step 1.
Problems like that doesn't matter when you put like the minus 2 or plus.
So what's the LCD? Okay. Yeah, x plus 2 times x minus 2, right? It's every factor you see is really just this one right there, right? So x plus 2 times x minus 2. Okay, what do you have to multiply? The first fraction, do you multiply by anything? It's already got it, right? So the second one you do, good, x minus 2 over x minus 2. Okay, that's the multiply each term. If you need to, right? We didn't have to multiply both. We just had to multiply one. Right? Now try to simplify by adding the numerators.
I mean, can't you get rid of the 1? Not get rid of it, but like get it in.
Right. You won't need the 1 in there. So what did you get for the numerator? X negative 2. Is it x times x? It's x plus x minus 2. What is x plus x? 2x. Right? It's not x times x, it's a plus in the middle. So that's 2x minus 2. What are the restrictions? Plus or minus 2, right? Plus or minus 2. So x does not equal 2, negative 2. Anything to simplify? You know, if you factored a 2 from both of those terms, you would have 2 times x minus 1. Then you still wouldn't be able to cancel anything. So you could just leave it like that. There's really nothing left to do. Most of the time you're going to get to this point where the denominator is still factored and the numerator is just a polynomial in standard form and it's just left like that. Unless you can kind of see that there's some simplifying to do. That's the normal way. Like, don't try to multiply the denominator. It's good like that. How many got 25% along the way? 50%? 75%? How many got all the way start to finish on that? No help.
I didn't get why you don't have them to the top.
What do you mean?
So
Here?
Yeah.
There's nothing to, what do we mean when we say simplify a fraction? It means cancel common factors. There's not going to be any common factors to cancel. Even if I factored out a 2 and had 2 times x minus 1, x minus 1 doesn't cancel with anything in the denominator. Neither does the 2. So that's done. All right, try it again. Same process. Next to the date. What kind of factoring? There's only one thing to factor here. What kind of factoring do you do there? What kind of factoring?
I know what it's called, but I can't see. Like the difference of.
It's not a difference of squares. Greatest common factor. What's the greatest common factor between these two?
How is it not difference of squares?
Because that's not a square. X by itself is not a square, so it's not a difference of squares. But there is a common factor, which is x, so factor it out of both terms. You know, when I'm doing these kinds of problems, I'm usually going to leave some space next to each fraction because I know I'm going to have to go back and multiply by something. And I don't want to have to jam it in there where there's no space. I can see in this one here, I'm only going to have to multiply the first fraction anyway, so I left some space here and I didn't leave any space there. So what was the LCD?
X minus 1.
Right. I mean, there's an x minus 1 here. There's an x and an x minus 1 here. The x minus 1s in each term is just to the first power. So it's x times x minus 1. Remember, the only time you would raise it to a power is if it was already squared in this one or in this one, then you'd have to make it squared. But it's not. So the second fraction already has that common denominator. What do you have to multiply the first fraction by so that it has the same denominator, x, right? So that these are the same, you need to multiply by x over x. So see if you can add the numerators now. You know what? I don't know if I can do that. That's probably right. What did you get for the numerator? So in this case, it'll be x times x, x squared, x times 1 plus x minus 2. Right? That's just, you got to do distributive property over here, right? And then you got to add the negative 2. Okay, what are the restrictions?
0.
Okay, 0 and 1. X does not equal 0. X does not equal 1. Okay. Now you got to look at that numerator. Could that be simple? Could that be factored in a way that we could cancel something?
Yeah.
I mean, how does x squared plus x minus 2 factor? It does factor.
I know it does. I just don't know how.
The products, the factors of negative 2 that add up to positive 1 are
1 and 2, negative 2. 1 and 1.
positive 2, negative 1, right? So this is going to be x plus 2 times x minus 1 over x times x minus 1. So in fact, there is going to be something to simplify here at the end, because there's an x minus 1 factor in the numerator and denominator. So cancel, cancel. And the answer is x plus 2 divided by x. Okay, those were addition problems. Subtraction, the steps are going to be the same. There's just one thing you got to be careful about with the subtraction. And I'm going to do this one. So the first step, factor the denominators.
It's not a U-chart, right?
No. X plus 2 over x times x minus 2 minus let me do this. Okay, it doesn't matter. No, I don't like doing it there. X plus 2 times x minus 2. Okay, I'm going to leave space in case I have to multiply, minus x plus 2 divided by 2 times x minus 2. Okay, the LCD. Remember, how do we make the LCD? We write down every factor in either denominator. So the first denominator is x times x minus 2, so that has to all be up there. Right, the second denominator has a 2. We didn't already have that, so I need to add that. And it has an x minus 2, but we already have an x minus 2. So I don't have to do that. So the least common denominator is 2x times x minus 2. Okay, what do I have to multiply the first fraction by so that it has the same denominator? Why does it always do that? Right, what is this denominator missing from the common denominator? It doesn't have a 2, right? So we need to multiply this one by 2 divided by 2. Right, what is the second fraction missing from the common denominator? It doesn't have the x, right? This doesn't have the x, so I multiply by x over x. Okay. So now here's the tricky part of when you're doing a subtraction problem. You got to understand that minus, which is in between the fractions, is going to flip the sign of every term in the numerator, right? That's not negative. Well, first we'll do this. This part here, that 2 times x plus 2 is 2x plus 4, right? And then we got a minus, and it's x squared plus 2x.
That's what's going over here.
Yeah, now we need to combine like terms here. Right? I just simplified this numerator, and I simplified this numerator. Now I need to combine them all and put the result there. So this will be 2x plus 4 minus x squared minus 2x. So that would give me negative x squared, 2x minus 2x, 0, cancel. And then the 4 plus 4. Right? The mistake we usually make is that we just write x squared plus 2x, and we end up adding 2x to 2x and not taking into account the minus changes the sign of that. Other than that, there's no difference between adding and subtracting rational expressions. Now, what are the restrictions looking at that there? 2, and again, from a standalone 0, from an x or standalone x, then 0, right? If you put a 0 there, then this whole thing turns into 0. So you say x is not equal 0 or 2. Now, could that one be simplified some more? Yeah, you know it could. If I do this, right? If I make this negative x squared minus 4 over 2x times x minus 2, right? I factored out a negative 1 from both of those. And now I got a difference of squares.
What if I came like that, would that be wrong?
Yes. It would be a little bit wrong, not much wrong. If you get it all the way through to here and just forget this last little point, for me, out of 5, maybe that's off 1. Right? I think that shows you understood pretty much everything. So now, because of that, x squared minus 4, this becomes negative x plus 2 times x minus 2 divided by 2x times x minus 2. And now I can cancel something, right? I can cancel the x minus 2's.
Well, why don't you change that to a negative right here?
Where? Here, I factored out the negative from both of those because I could see that if I did that, I would have an x squared minus 4 in parentheses. And there's an x minus 2 there, so there would be some simplifying to do.
That's not what I meant. You see how it's negative x2 plus 4? Down here is negative x.
Where?
It went from plus 4 to minus 4.
Here to here?
Yeah.
Because I factored out a negative, right? I mean, what is negative times negative? Positive. That's what happens when you factor out a negative. It flips the sign. Okay. You know, my intent was there's a couple more you tries, but I think given the time, I'm not going to do those now, but I will add them to the video and to the notes later. Okay. So we'll leave it at that. You know, if you're struggling with this, I mean, first you can watch the videos while you're doing the homework. That could like drag you through step by step. Second, you could come to tutoring. I'm here every day, right? If you're not willing to do any of that stuff, you know, I've done everything I can.
Yeah. So do you want us to wait to do the rest? Like, you want to try in or wait for?
Just turn in what you got. We should have 2, right?
Yeah,
2, and hand them in. If you don't hand them in, you don't get credit. You get a 0, right? Okay, this is appended onto the end of the first video. because we really didn't have time to get to it in class, but I'm going to finish it out anyways. It was intended to be a couple U tries. So let's see, we are subtracting rational expressions. And I've got the steps that we're supposed to be following right here. Factor the denominators. Okay, in this case, we will write down, am I in the right pen mode and everything? Guess so. X plus 3 over x minus 2 . That looks bad. I'm going to leave some space because I'm pretty sure I'm going to have to multiply here. Minus and 6x minus 7. And I'm factoring the denominator. The factors of 2 that add up to negative 3 are negative 2 and negative 1. So that's factored. That will make our LCD, right? The first term has got a denominator of x minus 2, which means it has a factor of x minus 2. So we need to have an x minus 2 up here. Right. The next term has got an x minus 2, but I don't need to add that because it's already there. And it has an x minus 1. Right. And both are raised to the first powers everywhere you see them, so that is the least common denominator. So what will I have to multiply the first fraction by so that it has the same common denominator? And the answer is, it's missing the x minus 1, right? The second fraction has an x minus 1 in the denominator. This one doesn't. So I do x minus 1 over x minus 1, which in the end is 1. Anything divided by itself is 1. So we're allowed to multiply by 1. Okay, so now when you add fractions that have the same denominator, you're just going to add or subtract. You're just going to, in this case, subtract the numerators. So let's see. This first, in order to save a little space here, this here is a FOIL, right? X plus 3 times x minus 1. And I'm not going to dwell on it, but this is x squared plus 2x minus 3. And if you're not sure, then take a step and take a minute and actually FOIL it for yourself, and you'll see where that comes from. So we are, the denominator is going to be x minus 2, x minus 1, and now we are combining the numerators. In this case, subtracting the numerators. Now again, the thing you have to keep in mind is, having this expression 6x minus 7 over a fraction bar is like a grouping symbol, right? It's an implied parentheses, which means that this minus is affecting both terms inside. It's going to make this minus a negative 7 into a plus 7 when I'm combining. So the first term will be x squared. There's no other x squareds here, so I definitely have an x squared. Then I've got a 2x, which will be minus 6x, which is minus 4x. And I'll have a negative 3 minus negative 7, which is negative 3 plus 7, which is plus 4. So at that point, you need to identify your restrictions. Because this one, like the others we've done, it looks like it is going to simplify a little bit. All right, so the restrictions are the zeros of the denominator. In this case, x does not equal 2 or 1. And now I can factor the numerator. The numerator is x minus 2 times x minus 2 divided by x minus 2 times x minus 1. And so now we have common factors that we can cancel. And we do. So the answer is x minus 2 over x minus 1. Right? Again, the answer is what we just got here, along with the restrictions on x. Okay, next. Another example of a subtract. Right? The first step, factor the denominators. I'm going to leave myself some space because I can be pretty sure that I'm multiplying this fraction by something. Right? It'll be minus x plus 3 divided by x squared plus 6x plus 5. Oh, what did I do? The whole point of this step was to factor. X plus 5 times x plus 1. Right, the LCD, least common denominator, will have an x plus 5 in it and an x plus 1. Right? And what will I multiply the first fraction by so that it has the same common denominator? I will multiply it by x plus 1. So x plus 1 over x plus 1. Right, now we can add the numerators. Since everything has the same denominator, we will add or combine or subtract, actually, the numerators. So this here, x minus 1 times x plus 1 is x squared minus 1. Right? And when I combine, I'll get x squared. There is a negative x, and then it'll be minus 1, negative 1 minus 3, which is minus 4. I hope I got that right. It looks like it. Remember that this minus sign is changing the sign of both terms in the numerator of the second fraction. All right, so negative 1 minus 3, negative 4. And we have x plus 5 times x plus 1. Right, state the restrictions. X does not equal negative 5 or negative 1. And then simplify if you can. Well, I'm looking at that numerator, unless I did something wrong here, which is not altogether unprecedented. That's not factorable. Can you think of factors of negative 4 that add up to negative 1? And the only factors of negative 4 would be the 1 times a negative 4, a negative 1 times a 4, or a negative 2 times 2. And none of those add up to negative 1. So this is not factorable. X squared minus x minus 4 is not factorable, which means there's nothing more you can do to simplify. The answer is all of that. Okay, so you need to be practicing this. We know it's not easy. It's not easy for anybody, any year. But you've got a lot of resources available. Take advantage of them.